Howard Thomas Odum was an American ecologist. He is known for his pioneering work on ecosystem ecology, and for his provocative proposals for additional laws of thermodynamics, informed by his work on general systems theory. Biography. Odum was the third child of the American sociologist Howard W. Odum, and the brother of Eugene Odum. Their father encouraged his sons to go into science and to develop new techniques to contribute to social progress. Howard learned his early scientific lessons about birds from his brother, about fish and the philosophy of biology while working after school for the marine zoologist Robert Coker, and about electrical circuits from the boy electrician by Alfred Powell Morgan. Howard Thomas studied biology at the University of North Carolina at Chapel Hill, where he published his first paper while still an undergraduate. His education was interrupted for 3 years by his World War II service with the Army Air Force in Puerto Rico and the Panama Canal Zone, where he worked as a tropical meteorologist. After the war, he returned to the University of North Carolina and completed his B.S. in zoology in 1947. In 1947, Odum married Virginia Wood. They had 2 children. After her 1973 death, he married Elizabeth C. Odum in 1974. She had 4 children from her previous marriage. Odum's advice on how to manage a blended family was to be sure to keep talking. Elizabeth's was to hold back on discipline and new rules. In 1950, Howard earned his Ph.D. in zoology at Yale University, under the guidance of G. Evelyn Hutchinson. His dissertation was titled The Biogeochemistry of Strontium, with discussion on the ecological integration of elements. This step took him from his early interest in ornithology and brought him into the emerging field of systems ecology. Through this, a meteorologist analysis of the global circulation of strontium anticipated in the late 1940s the view of the Earth as one great ecosystem. While at Yale, Howard began his lifelong collaborations with his brother Eugene. In 1953, they published the first English-language textbook on systems ecology, Fundamentals of Ecology. Howard wrote the chapter on energetics, which introduced his energy circuit language. They continued to collaborate in research as well as writing for the rest of their lives. For Howard, his energy systems language was itself a collaborative tool. From 1956 to 1963, Odum worked as the director of the Marine Institute of the University of Texas. During this time, he became aware of the interplay of ecological, energetic and economic forces. He then taught at the University of North Carolina at Chapel Hill, where he was in the Department of Zoology, and one of the professors in the new curriculum of marine sciences until his move to the University of Florida in 1970, where he taught at the Environmental Engineering Sciences Department. Started and directed the Center for Environmental Policy and founded the university's Center for Wetlands in 1973, the first of its kind in the world that is still in operation today. Odum continued this work for 26 years until his retirement in 1996. In the 1960s-1970s, Odum was also chairman of the International Biological Programme's Tropical Biome Planning Committee and was supported by large contracts with the United States Atomic Energy Commission with nearly 100 scientists, which involved radiation studies of a tropical rainforest. His featured project at University of Florida in the 1970s was on recycling treated sewage into cypress swamps. One of the first projects that began the now widespread approach of using wetlands as water quality improvement ecosystems. This is one of his most important contributions to the beginnings of the field of ecological engineering. In his last years, Odum was graduate research professor emeritus and director of the Center for Environmental Policy. He was an avid birdwatcher in both his professional and personal life. The Ecological Society awarded Odum its Mercer Award to recognize his contributions to the study of the coral reef on Eniwetok Atoll. Odum also received the French Prix de Vie, and the Crafoord Prize of the Royal Swedish Academy of Science, considered the Nobel equivalent for bioscience, not originally honored by Nobel himself. Charles A. S. Hall has called Odum one of the most innovative and important thinkers of our time, noting that Howard Odum, either alone or with his brother Eugene, received essentially all of international prizes awarded to ecologists. The only higher education institute to award both Odum brothers honorary degrees was The Ohio State University, which honored H.T. in 1995 and Gene in 1999. Odum's contributions to this field have been recognized by the Mars Society, who named their experimental station the H.T. Odum Greenhouse, at the suggestion of his former student Patrick Kangas. Kangas and his student, David Blesh, made significant contributions to the design of the wastewater recycling system. Odum's students have carried on his work at institutions around the world, most notably Mark Brown at the University of Florida, David Tilley and Patrick Kangas at the University of Maryland, Daniel Campbell at the United States Environmental Protection Agency, Enrique Ortega at the UNICAMP in Brazil, and Sergio Elgiati at the University of Siena. Work done at these institutions continues to evolve and propagate the Odum's concept of emergy. His former students Bill Mitch, Ohio State University, Robert Costanza, Portland State University, and Scott W. Nixon, University of Rhode Island, are among the cadre of former students who have been recognized internationally for their contributions to ecological engineering, ecological economics, ecosystem science, wetland ecology, estuarine ecology, ecological modeling, and related fields. Work. An overview. Odum left a large legacy in many fields associated with ecology, systems, and energetics. He studied ecosystems all over the world, and pioneered the study of several areas, some of which are now distinct fields of research. According to Hall, Odum published one of the first significant papers in each of the following areas: ecological modeling, ecological engineering, ecological economics, estuarine ecology, tropical ecosystems ecology, general systems theory. Odum's contributions to these and other areas are summarized below. Odum also wrote on radiation ecology, systems ecology, unified science, and the microcosm. He was one of the first to discuss the use of ecosystems for life support function in space travel. Some have suggested that Odum was technocratic in orientation, while others believe that he sided with those calling for new values, ecological modeling, a new integrative approach in ecology. In his 1950 Ph.D. thesis, H.T. Odum gave a novel definition of ecology as the study of large entities at the natural level of integration. Hence, in the traditional role of an ecologist, one of Odum's doctoral aims was to recognize and classify large cyclic entities. However, another of his aims was to make predictive generalizations about ecosystems, such as the whole world, for example. For Odum, as a large entity, the world constituted a revolving cycle with high stability. It was the presence of stability which Odum believed enabled him to talk about the teleology of such systems. Moreover, at the time of writing his thesis, Odum felt that the principle of natural selection was more than empirical, because it had a teleological, that is, of stability over time, component. And as an ecologist interested in the behavior and function of large entities over time, Odum therefore sought to give a more general statement of natural selection, so that it was equally applicable to large entities as it was to small entities traditionally studied in biology. Hence Odum also had the aim of extending the scope and generality of natural selection, to include large entities such as the world. This extension relied on the definition of an entity as a combination of properties that have some stability with time. Odum's approach was motivated by Locke's ideas on the energetics of evolution. Ecosystem simulation. In writing a history of the ecosystem concept, Golly noted that Odum tended to think in the form of analogies, and gave the example, if the world is a heat engine, then, in this vein, Odum can be understood as extending the dynamical analogies which establish the analogies between electrical, mechanical, acoustical, magnetic and electronic systems, to include ecological systems. Odum used an analog of electrical energy networks to model the energy flow pathways of ecosystems. Odum's analog electrical models had a significant role in the development of his approach to systems and have been recognized as one of the earliest instances of systems ecology. Electron flow in the electrical network represented the flow of material in the ecosystem. Charge in a capacitor was analogous to storage of a material, and the model was scaled to the ecosystem of interest by adjusting the size of electrical component. Ecological analog of Ohm's law. In the 1950s, Odum introduced his electrical circuit diagrams of ecosystems to the Ecological Society of America. He claimed that energy was driven through ecological systems by an ecoforce, analogous to the role of voltage in electrical circuits. Odum developed an analog of Ohm's law which aimed to be a representation of energy flows through ecosystems. In terms of steady-state thermodynamics, Ohm's law can be considered a special case of a more general flux law, where the flux with conductivity. In this simulation, Odum attempted to derive an ecological analog for electrical voltage. Voltage, or driving force, is related to something we have measured for years, the biomass, in pounds per acre. The analogous concept required is the biomass activity, that is, the thermodynamic thrust, which may be linear. Exactly what this is in nature is still uncertain, as it is a new concept. Such a consideration led Odum to ask two important methodological questions. 1. What is the electrical significance of a function observed in nature? 2. Given an electrical unit in a circuit, what is it in the ecological system? For example, what is a diode in nature? One needs a diode to allow biomass to accumulate after the voltage of the sun has gone down. Otherwise the circuit reverses. Higher organisms like fish are diodes. The Silver Springs study. Silver Springs is a common type of spring-fed stream in Florida, with a constant temperature and chemical composition. The study Howard Odum conducted here was the first complete analysis of a natural ecosystem. Odum started with an overall model and in his early work used a diagramming methodology very similar to the Sankey diagrams used in chemical process engineering. In this model, energy and matter flows through an ecosystem. H are herbivores, C are carnivores, T are top carnivores, and D are decomposes. Squares represent biotic pools and ovals are fluxes or energy or nutrients from the system. Started from that overall model, Odum mapped in detail all the flow routes to and from the stream. He measured the energy input of sun and rain, and of all organic matter, even those of the bread the tourists threw to the ducks and fish, and then measured the energy that gradually left the spring. In this way he was able to establish the stream's energy budget. Energetics. Ecological and biological energetics. Around 1955, Odum directed studies into radioecology, which included the effects of radiation on the tropical rainforest at El Verde, Puerto Rico, and the coral reefs and ocean ecology at Eniwetok Atoll. The Odum brothers were approached by the Atomic Energy Commission to undertake a detailed study of the atoll after nuclear testing. Apparently the atoll was sufficiently radioactive that upon their arrival the Odums were able to produce an autoradiographic image of a coral head by placing it on photographic paper. These studies were early applications of energy concepts to ecological systems. They were exploring the implications of the laws of thermodynamics when used in these new settings. From this view, biogeochemical cycles are driven by radiant energy. Odum expressed the balance between energy input and output as the ratio of production to respiration, PR. He classified water bodies based on their PR ratios. This separated autotrophic from heterotrophic ecosystems. His measurements of flowing water metabolism were measurements of whole systems. Odum was measuring the community as a system, not adding up the metabolism of the components as Lindemann and many others had done. This reasoning appears to have followed that of Odum's doctoral supervisor, G. E. Hutchinson, who expressed the view that if a community were an organism then it must have a form of metabolism. However, Golly notes that H. T. Odum attempted to go beyond the reporting of mere ratios, a move which resulted in the first serious disagreement in systems energetics. Maximum power theory and the proposal for additional laws of thermodynamics, energetics in a controversial move. Odum, together with Richard Pinkerton, was motivated by Alfred J. Lotke's articles on the energetics of evolution, and subsequently proposed the theory that natural systems tend to operate at an efficiency that produces the maximum power output, not the maximum efficiency. This theory in turn motivated Odum to propose maximum power as a fundamental thermodynamic law. Further to this, Odum also mooted two more additional thermodynamic laws. But there is far from consensus in the scientific community about these proposals, and many scientists have never heard of H. T. Odum or his views. Energy systems language. By the end of the 1960s, Odum's electronic circuit ecological simulation models were replaced by a more general set of energy symbols. When combined to form systems diagrams, these symbols were considered by Odum and others to be the language of the macroscope, which could portray generalized patterns of energy flow. Describing such patterns and reducing ecosystem complexities to flows of energy, Odum believed, would permit discovery of general ecosystem principles. Some have attempted to link it with the universal scientific language projects which have appeared throughout the history of natural philosophy. Kitching claimed that the language was a direct result of working with analog computers, and reflected an electrical engineer's approach to the problem of system representation. Because of its electrical analogy, the Odum system is relatively easy to turn into mathematical equations. If one is building a model of energy flow, then certainly the Odum system should be given serious consideration. Due to the focus on systems thinking, Odum's language appears to be similar in approach to the systems modeling language recently developed by INCOSE and International Systems Engineering body. Energy quality. And taking an energy-based view of hierarchical organization, Odum also developed further the systems ecology understanding of energy quality. Emerging in the 1990s. In the latter part of his career, H. T. Odum together with David M. Scienceman developed the ideas of emergy as a specific use of the term embodied energy. Some consider the concept of emergy, sometimes briefly defined as energy memory, as one of Odum's more significant contributions. However, the concept is neither free from controversy nor without its critics. Odum looked at natural systems as having been formed by the use of various forms of energy in the past. Emergy is a measure of energy used in the past and thus is different from a measure of energy now. The unit of emergy is the mjoule, as distinguished from joules used for available energy remaining now. This was then conceived as a principle of maximum power which might explain the evolution of self-organizing open systems. However, this principle has only been demonstrated in a few experiments and is not widely recognized in the scientific community. Ecosystem arcology and systems ecology. Main articles: Ecosystem arcology and systems ecology for J.B. Hagen. The maximum power principle and the stability principle could be easily translated into the language of homeostasis and cybernetics systems. Hagen claims that the feedback loops in ecosystems were, for Odum, analogous to the kinds of feedback loops diagrammed in electronic circuits and cybernetic systems. This approach represented the migration of cybernetic ideas into ecology and led to the formulation of systems ecology. In Odum's work, these concepts form part of what Hagen called an ambitious and idiosyncratic attempt to create a universal science of systems. The ecosystem concept macroscope. Hagen has identified the systems thinking of Odum as a form of holistic thinking. Odum contrasted the holistic thinking of systems science with reductionistic microscopic thinking, and used the term macroscope to refer to the holistic view, which was a kind of detail eliminator, allowing a simple diagram to be created. Microcosms. H.T. Odum was a pioneer in his use of small closed and open ecosystems in classroom teaching. These small ecosystems were often constructed from fish tanks or bottles and have been called microcosms. Odum's microcosm studies influenced the design of Biosphere 2. Hierarchical organization. In observing the way higher order trophic levels have a control function in ecosystems, H.T. Odum arrived at the concept he termed hierarchical organization. Ecological economics. Ecological economics is now an active field between economics and ecology, with annual conferences, international societies and an international journal. From 1956 to 1963, H.T. Odum worked as director of the Marine Institute of the University of Texas. During this time, Odum became aware of the interplay of ecological, energetic and economic forces. He therefore funded the research into the use of conventional economic approaches to quantify dollar values of ecological resources for recreational, treatment and other uses. This research calculated the potential value of primary production per base surface area. For Hall, the importance of Odum's work came through his integration of systems, ecology, and energy with economics, together with Odum's view that economics can be evaluated on objective terms such as energy rather than on a subjective, willingness to pay basis. It was titled The Biogeochemistry of Strontium, with discussion on the ecological integration of elements. This step took him from his early interest in ornithology and brought him into the emerging field of systems ecology. Through this, a meteorologist analysis of the global circulation of strontium anticipated in the late 1940s the view of the Earth as one great ecosystem. While at Yale, Howard began his lifelong collaborations with his brother Eugene. In 1953, they published the first English-language textbook on systems ecology, fundamental to his B.S. in zoology in 1947. In 1947, Odum married Virginia Wood. They had 2 children. After her 1973 death, he married Elizabeth C. Odum in 1974. She had 4 children from her previous marriage. Odum's advice on how to manage a blended family was to be sure to keep talking. Elizabeth's was to hold back on discipline and new rules. In 1950, Howard earned his Ph.D. in zoology at Yale University, under the guidance of G. Evelyn Hutchinson. His dissertation, Philosophy of Biology, while working after school for the marine zoologist Robert Coker, and About Electrical Circuits from the Boy Electrician by Alfred Powell Morgan. Howard Thomas studied biology at the University of North Carolina at Chapel Hill, where he published his first paper while still an undergraduate. His education was interrupted for 3 years by his World War II service with the Army Air Force in Puerto Rico and the Panama Canal Zone, where he worked as a tropical meteorologist. After the war, he returned to the University of North Carolina and completed of ecology. Howard wrote the chapter on energetics, which introduced his energy circuit language. They continued to collaborate in research as well as writing for the rest of their lives. For Howard, his energy systems language was itself a collaborative tool. From 1956 to 1963, Odum worked as the director of the Marine Institute of the University of Texas. During this time, he became aware of the interplay of ecological, energetic, and economic forces. He then taught at the University of North Carolina at Chapel Hill, where he was in the department of. Howard Thomas Odum was an American ecologist. He is known for his pioneering work on ecosystem ecology, and for his provocative proposals for additional laws of thermodynamics, informed by his work on general systems theory. Biography. Odum was the third child of the American sociologist Howard W. Odum, and the brother of Eugene Odum. Their father encouraged his sons to go into science and to develop new techniques to contribute to social progress. Howard learned his early scientific lessons about birds from his brother, about fish and the